Welcome to Sopil Study Circle. My name is Satish, and today we are learning the lesson number 2 of 10th standard CBSE polynomial, and this is the first part of this lesson. Okay, in this part, we are learning what is the polynomial, okay, types of polynomial, as well as what is the relation between the zeros of the polynomial and its coefficient. Okay, so let's see polynomial. Uh, we know that in algebraic expression, uh, first we know what is the algebraic expression. Okay, for example, suppose this is the rectangle, and suppose this is the length x, and suppose this is the breadth. Then perimeter of rectangle we can write in this way: 2 times length plus breadth. But we know that length is equal to x and breadth is equal to y. So this kind of expression is called algebraic expression. Why this is called algebraic expression? Because in this expression some unknowns are there. Some unknowns are there means there is x, there is y. So we can say whose values are not known. Therefore, this unknowns called variables. Okay, so x and y are variables here. So this is called algebraic expression whose values are not given in mathematical expression, that is called algebraic expression, which can be used to express some mathematical quantity. What this quantity is expressing here, यहाँ पे इस क्वांटिटी क्या यानी क्या क्या एक्सप्रेस कर रही है, तो यहाँ पे ये जो x है, ये जो y है, ये यहाँ पे पेरीमीटर एक्सप्रेस कर रही है. ठीक है, पेरीमीटर ऑफ रेक्टेंगल एक्सप्रेस कर रही है, इसीलिए हमने यहाँ पे x और y का यूज किया है. ठीक है, x का एक्सप्रेस x जो वेरिएबल है वो क्या एक्सप्रेस कर रहा है, यहाँ पर ये लेंथ एक्सप्रेस कर रहा है, और जो y है वो ब्रेथ एक्सप्रेस कर रहा है. तो हम कुछ भी जैसे मैथमेटिकल एक्सप्रेशन होते हैं, उसको अगर हमें मैथमेटिकल लैंग्वेज में अगर लिखना है, सिंबल में लिखना है, तो हम उसको लिख सकते हैं सम अननोन का यूज करके. ठीक है, जो अननोन का यूज करते हैं उसको हम वेरिएबल बोलते हैं. ठीक है, तो ये सब हम लास्ट ईयर या मेरे ख्याल से 8th स्टैंडर्ड में हम लोगों ने ये सब कुछ चीजें पढ़ी है. तो वेरिएबल क्या होता है. ठीक है, सो दिस इज कॉल्ड वेरिएबल. ठीक है, वेरिएबल वगैरह मैंने आपको बता दिया क्या होता है. जिसकी क्वांटिटी पता नहीं होती उसको वेरिएबल बोला जाता है. तो इस टाइप के एक्सप्रेशन को हम अलजेब्रिक एक्सप्रेशन बोलते हैं. वी कॉल सच काइंड ऑफ एक्सप्रेशन अलजेब्रिक एक्सप्रेशन. उसके बाद जब ये अलजेब्रिक एक्सप्रेशन बनते हैं, और इफ this is algebraic expression, then what is called polynomial. Okay, so suppose so many algebraic expression are there. For example, like this way: example x plus 1 upon x. Second example, minus x to the power minus 2 plus x plus 6. Third example, y square plus y to the power 3 plus 9, etc. like this way. Fourth example, under root of t plus t, like this way. So now in these examples, example 1, example 2, example 3, example 4. So in example 1, variable is x. Okay, and there is there are two terms. One is x, second is 1 upon x. Okay, so obviously this is algebraic expression, ये algebraic expression है, लेकिन ये polynomial नहीं है. But this is not a polynomial. Why? Because the degree of this term is 1. First see what is the term. Terms in algebraic expression are those quantity which are connected by plus और minus sign. ठीक है, ऐसी क्वांटिटी algebraic expression में जो प्लस और माइनस से कनेक्ट होती है उसको बोलते हैं टर्म. So in this example there are two terms. One is the first term is x, second term is 1 upon x. Okay, but in polynomial we check the degree of each term. Okay, now in the first example the first term degree is 1. Degree means highest power of variable. So highest power of this term is 1, but here this is 1 upon x. So 1 upon x we can write in this way, x to the power minus 1. So obviously the degree of the second term is minus 1, and in the polynomial the degree of each term is positive. Okay, each term, हर टर्म की डिग्री पॉजिटिव होनी चाहिए, या वो जीरो भी रही तो चलेगा लेकिन पॉजिटिव होनी चाहिए, तभी उसको हम पॉलिनोमियल बोलते हैं. ठीक है, तो उसकी मैं डेफिनेशन लिख के दूंगा आपको. अब सेकंड एग्जांपल देखो, यू कैन सी द सेकंड एग्जांपल. तो सेकंड एग्जांपल में क्या है, सेकंड एग्जांपल में जो फर्स्ट टर्म है उसकी डिग्री ऑलरेडी -2 है. तो ये अलजेब्रिक एक्सप्रेशन है लेकिन इसको हम पॉलिनोमियल नहीं बोल सकते. सो दिस इज नॉट पॉलिनोमियल, दिस इज नॉट पॉलिनोमियल. थर्ड एग्जांपल देखते हैं. थर्ड एग्जांपल में फर्स्ट टर्म की डिग्री 2 है, y की डिग्री भी 3 है, ये पॉजिटिव है, और 9 ये कांस्टेंट नंबर है. तो कांस्टेंट नंबर की डिग्री हमेशा 0 होती है. ठीक है, ये हमने लास्ट ईयर में पढ़ा था. लास्ट ईयर में हमने बहुत कुछ पढ़ा था पॉलिनोमियल के बारे में. लास्ट ईयर में हमने पढ़ा था कि पॉलिनोमियल में कौन से टाइप की डिग्री होती है, उस डिग्री के नाम पढ़े थे. जैसे अगर डिग्री 1 है तो उसको लीनियर पॉलिनोमियल बोला जाता है. सपोज अगर उसकी डिग्री 2 है तो उसको क्वाड्रेटिक पॉलिनोमियल बोला जाता है. सपोज द डिग्री 3 है, so then we call cubic polynomial. If the degree is 4, then we call biquadratic polynomial. So we are going to learn this year. This year also we are recalling this thing. But before that, let's see what is the algebraic expression and what is the difference between the algebraic expression and polynomial. Okay, so in polynomial we consider the degree and we consider the variable also. Suppose we are dealing with the polynomial with two variables, so we consider two variable. If we are dealing with the one variable, so one variable should be there. Okay, so in this all example only single variable is there. For example, x square plus y square. So in this example x square and y square, two terms are there. Okay, but there are two different variables. One variable is x, second variable is y. So this is also polynomial, but this is the polynomial of two variable. Okay, so polynomial are of different type according to variable and degree. Okay, now we are dealing here the polynomial with single variable. Okay, so in first example this is algebraic expression because unknown quantities are there, two terms are there, but this is not polynomial because the degree is here minus, negative of second term. In the second example you can see variable is x, but degree of first term is -2, so obviously this is not polynomial. In the third term you can see the degree of each term is here positive, 2 then 3 then 9. 9 is a constant number, so it is also polynomial. This is polynomial. And in the fourth term, in the fourth example, degree of t of first term is 1/2. We know that power of under root or indices of under root is 1/2. In loss and exponent last year we learned what is the degree, what is the index of the under root. So degree of under root is 1/2. So it does not follow the positive integer. Only integer should be the degree of term of each term of polynomial. Okay, so obviously even the degree of second term is 1, but we check the degree of each term. So degree is here 1 by 2. That's why this is also not polynomial. So this was just general thing. Now I explain you the polynomial in detail. Okay, let's see now. So this is the definition of polynomial. Okay, an algebraic expression in which degree of each term is non-negative integer is called polynomial. Example: x square plus x minus 6 is the first example of polynomial. Second example, you can write x square plus y square plus 9. So these are examples of polynomial. This is the example of polynomial in single variable, and this is the example of polynomial in two variable. Okay, these are the polynomial of different variable, and this is the definition of polynomial. So you can write. Now classification of polynomial based on degree. Okay, uh, generally there is a classification of polynomial based on terms also, but we are not dealing with or we are not learning about the terms, so we just focus on classification of polynomial based on degree. So let's see first types of polynomial. If suppose I write here example of polynomials. Here I write name, and here I write degree. Okay, so we know that degree of polynomial is highest power of variable is called degree. Okay, for example, suppose I take x plus 5. Two terms are there. Okay, and degree of x is 1 here, highest power. Therefore the name of this polynomial is linear, and here we can write the general form ax plus b. This is general form, and degree is here 1. So all important things I cover in one chart. Second example, x square minus 9. Even in this example two terms are there. Okay, means it is binomial, but actually the degree of x is here 2. So this is called quadratic. And the general form is here x square plus px plus c, and degree is here 2. Highest power of x is 2 here. Now suppose I take another example, y to the power 3 minus y square minus 11. Total 3 terms are there, but the degree of this y is 3. So we call this is cubic polynomial. Okay, and general form is here ax cube plus bx square plus cx plus d, and degree is here 3, in this way. And suppose example 4, if the degree is 4, like y to the power 4 minus 6, even in this example, two terms are there, but degree is matter here. Degree of this expression is 4. So this is called biquadratic polynomial. And general form is here ax to the power 4 plus bx cube plus cx square plus uh, dx plus e, like this way, and degree is here 4. So you have to remember 4 points here. First, if the degree is 1, then this is called linear polynomial, and this is the general form of the linear polynomial ax plus b. Okay, if the degree is 2, then it is called quadratic polynomial. This is the general form ax square bx plus c, and degree is 2. If degree is 3, highest power of variable, this is the degree 3. Okay, even there are 2 degree, there is 3 degree, but we select only highest power. Okay, so highest power is 3. So this is called cubic polynomial, and that is the general form x cube plus bx square plus cx plus d, highest power 3. Degree 4, 2 terms are there, name is biquadratic. This is the general form, degree 4. All these things are given in your textbook. Okay. Now, uh, this is the 2 more polynomial. Okay, and these 2 polynomial also are mentioned in the textbook. Okay, one is एक है constant polynomial और second is zero polynomial. ठीक है, so this constant polynomial means what? Numbers, only numbers. Okay, for example, suppose numbers are there like this -100 or for example 50, like this way. If suppose these numbers are there, so this numbers is called constant polynomial, and the degree of constant polynomial is always 0. हमें ये बात ध्यान में रखना है कि अगर सपोज डिग्री पूछा है व्हाट इज द डिग्री ऑफ कांस्टेंट पॉलिनोमियल, देन वी कैन इजीली से द डिग्री ऑफ कांस्टेंट पॉलिनोमियल इज 0. Okay, why this is 0? For example, suppose I write 5. 5 is constant polynomial, but in polynomial form we can write in this way: 5 into x to the power 0. And we know that x to the power 0 is equal to 1 is equal to 5, because x to the power 0 is equal to 1. So in this way we can write any constant number in polynomial form by taking any variable. Okay, but the point should be noted that the degree of that variable should be 0. That's why degree of constant polynomial is 0. So these are the example of constant polynomial. Then zero polynomial. Zero polynomial means only 0. So this 0 is called zero polynomial. Means we can say in the zero polynomial all the terms are 0. Okay, all the coefficient of the terms are 0. All the coefficient of the terms are 0 means what? Like this way: 0 x to the power 4 plus 0 x to the power 3 plus 0 x square, like this way. So 0 is the coefficient of x to the power 4, 0 is the coefficient of x to the power 3, 0 is the coefficient of x square, in this way. So all the coefficient are 0, then such polynomial is called zero polynomial. So this is the meaning of zero polynomial. I hope you understood, all of you. Now this is very important topic of the polynomial, that is called zeros of polynomial. Okay, in this topic we are learning how to find zeros of polynomial. See, zero polynomial and zeros of polynomials are two different things. In last time I told you about the zero, zero polynomial in which all coefficient are zero, but this is the zeros. In another word, zeros means solution of polynomial, or it is also called root of polynomial. But in mathematics book, the word is given zeros of polynomial. Let's see what is the meaning of zeros of polynomial. For example, if I take 5x plus 2, this is linear polynomial, and I want to find zeros of this polynomial. So how can I find? First, I consider here, let 5x plus 2 is equal to 0. Then first I shift the constant number that side. So this become 5x equal to minus 2. So x equal to minus 2, 5 goes in division by 5. So x equal to minus 2 by 5 is zeros of this polynomial. Why? Suppose I put here x equal to minus 2 by 5 in this expression, I will get 0. Let's see, 5x plus 2 is equal to, in the place of x I will write out here minus 2 by 5 plus 2. Now 5 cut. So what is left here? Minus 2 plus 2. Minus 2 into 1, minus 2 plus 2, and this becomes 0. So means for value of x, if the whole expression becomes 0, then that value of x is called zeros of polynomial. So in this way we can understand the zeros of polynomial. So this is the linear polynomial. Okay. So in linear polynomial we can find 0 like this way. I will tell you how to find the zeros of linear polynomial. Okay. If ax plus b is linear polynomial, then x equal to minus b upon a is a zero of polynomial. Okay. So ax plus b is linear polynomial, then x equal to minus b upon a is a zero of polynomial. This is the relation between 0 and coefficient of variable. So we understood what is the meaning of 0. 0 means the value of x for which the value of expression or value of polynomial become 0. That is called zeros of polynomial. I will write the definition also. But suppose this is the linear polynomial, then you can directly find out the 0 by this formula. X equal to minus b upon a is 0 of polynomial. Example, 2x plus 5. Then 0 we can find, this is the general form, ax plus b. So from this general form, a is equal to 2 because coefficient of x 2, and b is equal to 5. Okay. So minus b upon a, so this is equal to minus, already minus is there, so this is minus, and b value is here 5 and a value is here 2. So in this way we can find out the zeros of polynomial, of linear polynomial. Okay. Not we cannot find out quadratic polynomial by this method. We can find out zero of linear polynomial. Okay. See here, if p of x is a polynomial of degree greater than 0, it should be greater than 0. This is the compulsory. Okay. If the suppose the degree is 0, then we can't find out the zeros there. Okay. This is not possible. If the degree 0 means it's the constant number, so how can you make the 0? But keeping the 0 only, it make 0, but this doesn't give the satisfactory answer. Okay. So if polynomial, if f of x or p of x, these are the just symbol used for polynomial. If p of x is a polynomial of degree greater than 0 and x equal to k, means x equal to k, k is what here? K is real value, any real value. It can be 2, it can be 5, it can be 2 by 5, etc. And if p of k is equal to 0 means suppose in the place of x you put down the k, ठीक है, x की जगह पर अगर आपने वहां पे k पुट किया और उस पॉलिनोमियल की वैल्यू सपोज 0 बन रही है, जैसे लास्ट ईयर में हमने पढ़ा था पॉलिनोमियल में वैल्यू कैसे फाइंड करते हैं। अगर पूरे पॉलिनोमियल की वैल्यू इफ द वैल्यू ऑफ होल पॉलिनोमियल बिकम 0 आफ्टर putting x equal to k in the expression, then x equal to k is called zero of polynomial. This is the definition of zero of polynomial. Now we are going to learn the relation between zero and coefficient of polynomial in linear polynomial. Let's see now. Now this is the topic we are going to learn, relation between zero and coefficient of polynomial of linear polynomial, ठीक है। So let's see, if ax plus b is linear polynomial, okay, this is the general form of linear polynomial, then we can find out the zero. So we know that how we can find out zero, x equal to minus b upon a. So only single relation is there in the linear polynomial. See, b and a are what? A is a coefficient of x and b is a constant coefficient. So this side is coefficient only and this side is a x. So we can say this is the relation. So in another word we can say here zero of linear polynomial is equal to minus constant upon coefficient of x. In this way we can frame one relation between zero and coefficient of linear polynomial. Okay, that is the relation. What is the relation is here? Zero of linear polynomial is equal to minus b is what here, constant term here, and what is the a here? A is here coefficient of x. This is the a means coefficient of x and b means constant. So minus already there minus, so this is the minus, and constant means b and coefficient of x means a. So this is same. So student, till today we learn this thing. Okay, tomorrow I will explain the next topic, next part, that is graphical representation of the polynomial. We need the graph paper. I will explain you how to represent the zeros of, how to find out the zeros of polynomial with the help of graph, and how to how to find out the coordinate and how to plot this coordinate on the graph paper. We will see tomorrow in the next part, as well as we will see the relation, how to find out the zeros of the quadratic polynomial and what is the relation between zeros of the quadratic polynomial and coefficient of the quadratic polynomial. Okay, thank you.